Hello, this is our team, Vision Ventra, and we developed an innovation on vertical axis wind turbines. So starting off, we're going to talk about traditional horizontal axis wind turbines, and basically the downsides of them is that they're very non-space efficient. They take a lot of area. They have a lot of environmental damage. They kill a lot of birds. They're distant from cities, which means they're very expensive, and they're very expensive to maintain. Whereas with our vertical axis wind turbine, we excel in the cost-effective areas, such as recycled materials. It requires very minimal space, and our innovation will use current infrastructure such as light posts, so we can reduce costs even further, and because light posts are already connected to the grid, it'll make our design even cheaper.
This is our prototype we built, one of the two. I have an RPM meter using a small scale model to calculate the RPMs and the power output of a full scale model for demonstration purposes, so we can educate on what a full scale model of this wind turbine would look like and the kind of power it would generate. We used a simulated lift coefficient, or a simulated power coefficient from a research paper using the same windmill design, and estimated the power output.
All right, and then this is the generator component. The scale is not the same for the turbine. The only utilized portion is this top row of solenoids for it. One half is crossed, one half is uncrossed to keep the fluxes from canceling out. And we also have an outer shell with magnets that will rotate alongside this. It is in 4-phase and it's currently radial flux. This is the outer shell with magnets on the inside.
As you can see, when I move this in a perpendicular direction to the copper coils, you can see it induces a current. You can clearly see with these graphs that with our design, which is the black line, it clearly outperforms current other designs for vertical axis wind turbines. And so moving forward, this is just on paper, but moving forward, we're going to be testing in real life.
After this rigorous testing, we have discovered several flaws with our current design. First of all, our design aspect, the outside blades, should be flipped around the other way. Also, we have to change our generator to 3-phase instead of 4, make it generate actual flux based on base instead of radial flux. And increase diameter of a magnet container so that it can spin around on the generator.
Here are references we used for the slideshow, and here's all the previous sources we cited.